Hello there, Matt with Linbit here. In the following video, I'll demonstrate extending an existing LinStore managed DRBD volume to a disaster recovery node located in a geographically separated data center via LinStore and DRBD proxy. I've already created a LinStore cluster on 4 nodes, LinStore A, B, C, and LinStore DR. And we can see that LinStore DR is in a different network than our other 3 nodes. This network exists in the DRDC, which is connected to our local DC via 40 megabit per second WAN link. I have a single DRBD resource defined, which is currently replicated synchronously between the 3 peers in our local DC. I've listed out our LinStore managed resource and volume, which is currently mounted on LinStore A. Before we add a replica of this volume to the DR node in our DR data center, we'll quickly test the write throughput of our DRBD device so we have a baseline for how well it should perform. And I'll just use this DD here as a test. Okay. So between 85 megabytes per second and 95 megabytes per second. And that's as fast as this storage can go. So we'll note that as our baseline. As a recap, DRBD can only perform as well as its slowest component among the replication network and storage subsystem of all the peers. Adding a DR node whose replication network spans a 40 megabit per second WAN link should therefore bottleneck our writes to 40 megabits per second. This is true even when using DRBD's asynchronous protocol A. DRBD proxy mitigates this bottleneck by acting as a buffer for our replication traffic. And I'll demonstrate that bottleneck by showing what happens with just DRBD stretched across long distances, and then we'll enable DRBD proxy so we can observe that difference in performance. So first, we'll extend our resource to our DR node using LinStore, and then we'll set DRBD's replication mode to asynchronous for each of the connections in our connection mesh. So this command will extend our DRBD device to the DR node. And then this command will set the protocol to asynchronous from each of our local nodes to our DR node. Okay, everything succeeded. So now we should see that our performance has been limited by the addition of the DR node. And this will be true until we enable DRBD proxy. But let's prove it. We'll run our test again. So 5.7, 6.1 megabytes per second. So we're getting a little help from protocol A because 5 megabytes per second is equal to 40 megabit per second, and I know that that is the limitation of that WAN link. So we do see a little help there from protocol A, but nowhere near the 85 to 95 megabytes per second we were seeing from our synchronous peers, from our local peers. So now let's enable DRBD proxy via LinStore for each connection in our mesh, and we'll adjust the buffer size up a little bit too to 100 megabytes from the default of 32. That's just a good starting point for your proxy buffer's memory limit. And then we'll rerun our test, and we should see that we're no longer being bottlenecked by that throughput. Okay. We've enabled proxy and increased the mem limit a bit. And we'll rerun our test. All right, there we see the bottleneck has in fact been removed. Also, don't worry if the commands I ran seem a bit daunting, as the LinStore drivers for your cloud platform should handle most of the heavy lifting for you. Dropping to the command line LinStore utility should only be required for more advanced tuning of resources. And to quickly recap, LinStore enabled us to extend our DRBD replicated volume across our WAN link. This adds disaster recovery capabilities to our already highly available block storage. And most importantly, it does that without impacting performance. Check out our other videos about installing LinStore with Kubernetes, OpenNebula, OpenStack, or as a standalone software-defined storage platform for your environment. If you have questions about anything you've seen here or about how LinStore would work in your project, head on over to limbit.com and reach out. But that's all for now. Thanks for watching. Don't forget to like and subscribe.